Hello and welcome to Golden Droplets episode number 29. My name is Ricardo Valls and I am the founder and president of vallsgeoconsultant. In today's episode, I'm going to be talking about VOXLER and how we can use this software to do resource estimations. And as always, I will let first the specialist from Golden Software to explain the technical characteristic of VOXLER, and then I will show you the way I work with it to do a full resource estimation. So once again, welcome to Golden Droplets 29.
Hi, my name is Drew and I'm the VOXLER product manager, and I'm here today to give you the lowdown on rendering well data in 3D. The first approach for importing well data into VOXLER, which has all the data combined into a single sheet, or what we call the XYZC path approach, is a more simple approach to data organization. Now I have an example of the XYZC path data open in VOXLER's worksheet window, so please take a look at this. In this approach, the coordinates for the well traces will already be calculated and are the true XYZ coordinates of the well trace. This well data organization structure can often include a log or sample values in the sample table or sheet as the path coordinates. This is why we call it a single sheet approach. So if we take a look at the active table I have open, you can see the required columns for this approach. There's a well ID column. Again, we have the true X, Y, and Z coordinates of the well trace, a measured depth column, azimuth and deviation columns, and finally we have a sample column of ore concentration. These are all the required components or columns for to use the XYZ path approach. Now for the second approach, typically well data, the curve data or logs, can be imported from one file, and the physical location of the well, or the collars table, will be imported from another file. We also often see trajectory data that includes the direction of the well traces on yet another or separate sheet or table that will also be imported when the well is not assumed to be vertical. When using the multiple table import approach like this, the well path has not been calculated, and VOXLER will make these calculations for you. So now let's focus in detail on the multi-table approach for organizing well data. I'm going to open a three-sheet XLS file that contains a collar table, which again defines the well top location, a directional survey table that defines the well trajectory along the well trace, and a samples table that defines the from-to intervals along the well trace that contain data. In the XLSS import options dialog, you can see that I have three tables to select from. The first one, I'm going to select the collars table and click open. I'm going to repeat these steps and open up the other two tables. You see, so I'm going to select the trajectories table, click open. And finally, the samples table, and open it. So now that the tables are open, you can see them on the three tabs at the top of the worksheet window: collars, trajectories, and samples. So first, let's take a look at the collars table. The collars table requires a well ID column, a top X column, which in this data it's titled Easting, a top Y column, which for this data is a northing value, a top Z or elevation, azimuth, dip, and total depth. As you can see, there's only a single record for each one of these wells. And again, this callers table will define the well top. Now let's take a look at the directional survey or trajectories table. Some people also refer to this table as a deviation survey. So the directional survey table requires 4 fields. Again, we see the well ID, a measured depth column, an azimuth column, and an inclination column. In this example data set, there are many records per well. You can see this as I scroll down. Now, in order for VOXLER to calculate the well trajectory, each well will need a minimum of 3 points along each well trace in the directional survey table. It's a very important item to keep in mind. Now finally, let's take a look at the third table, or the samples table. The sample table requires a well ID column, a measured depth column, or in this example I have a from to column, from and to columns. And then I also have one-to-many sample columns that have the data sample readings for that specific depth or interval. And you can see that I have 2 columns here with sample readings that reference the specific intervals. So I wanted to make note of the way these tables are connected or indexed to one another. They all use an ID column that must match the IDs for the other tables. So we see the ID column here in the samples, again in the trajectory table. Again, all these IDs must match. So this is what we call a unique identifier. And again, this identifier must match 100% to the identifiers on the other tables if you want the well data to render correctly in VOXLER. I'm going to close these tables really fast. Let's import the borehole data and see what it looks like graphically. So I'm going to import the 3 tables I discussed a few minutes ago, starting with the collars table. So I'm going to go ahead and use the file import command. In the import dialog, I'm going to select the data and click open. In the XLSS import options dialog, I want the collars table. So I'm going to make sure it's selected. I'm going to click OK. Now you can see that the data was added to the network manager. I'm going to go ahead and import the directional survey table at this time also. So in the import dialog, again, I'm going to select the same data sheet because I know it contains all 3 tables. I'm going to click open. This time I'm going to select trajectories and click OK. So now that the 2 tables have been imported, I need to make sure that the correct column assignments are set in the property manager. So what's nice about the new data import system in VOXLER is if you make a mistake setting the columns, you can quickly make an adjustment in the property manager and do not have to delete everything that you've already imported and start over. So to assign the correct columns for the collars table, I'm going to make sure I select it in the network manager. I'm going to move down to the property manager, and on the general tab, I'm going to first make sure that I set the output type to wells. Now this option can also be set to points, which would be used to import point data. So obviously if I was importing point data, I would change this output type to points. Now please notice when I toggle between the 2 options, the available fields in the property manager change to what's relevant and required for that particular data type. I'll expand this a little bit so you can see it. So the property manager is changing here when I toggle back between wells and points. Obviously we're dealing with wells. I'm going to keep the output type set to wells. So next, since the table I've selected is a collars table, I'm going to change the sheet type under well columns to collars. Now you can see when I open this drop-down menu that the different types of tables that we support are all listed here. I'm going to go ahead and select collars. Now this option is similar to the output type option in the sense that when it's set to a particular sheet type, only the relevant and required fields and information are being displayed in the property manager. So right here. So I'm going to make sure that all these fields are set correctly. And you can see in the drop-down menus that all the fields that were in the data are available. Let's make sure I got everything set correctly. Okay, great. Now that I have all the collars table parameters set, I need to do the same thing for the directional survey table. So in the network manager, I'm going to click the trajectory table and move back down to the property manager. Again, the output type needs to be set to wells. For the sheet type, we know that this is a directional survey or trajectory table. So I'm going to make sure that I have that set correctly. And then again, the required fields have now populated the property manager, and I'm going to make sure that these are set correctly. It looks like it. So all the required fields are set for the two well data tables I've imported. So now I can attach a well data module to both of these. You can think of the well data module as a container module where all the data gets combined and linked together, so it can be rendered in 3D. So to add the well data module, I'm going to select the collars table in the network manager. I'm going to right click and choose well data. I'm also going to connect the directional survey table to the well data module by dragging the connector from the trajectory table to the well data module. And when I'm prompted, I'm going to use connect input worksheet B. So now to verify that all the data has been blended and linked together in the well data module, I'm going to select it in the network manager, move to the property manager, select the wells tab, and expand one of these wells. So you can see right now that I have the top set. So I have the XYZ coordinates for these. And this is a really good indication that the data has been linked together. Now, let's see what these well traces or boreholes look like. So I'm going to go ahead and select the well data module in the network manager. I'm going to right click and choose graphics output, well render. Might be nice to add a bounding box and some axes here also. So I'm going to go ahead and do that real quick. So great, now you can see all the well traces in the boreholes with some nice deviation. The deviation algorithm is specified from the well data module as it was in past versions of VOXLER. But now VOXLER calculates the trajectory for you on the fly, so you don't have to live with straight well traces because you missed the compute paths button. This is, again, done automatically. If for some reason you don't like the algorithm that was used to calculate the trajectory, you can always change it by selecting the well data module in the network manager, moving down to the property manager and selecting the well paths tab, And then the path method can be changed here. So finally, for this example, I would like to import some interval data that I can render along the well traces. So to do so, I need to import some sample data. I'm going to click File, Import. Again, in the Import dialog, I'm going to navigate to the data and click Open. This time we want the samples table, so I'm going to select Samples in the Import Options dialog and click OK. Now again, I'm going to need to set the parameters for the samples table in the property manager before connecting it to the well data module. So with it selected in the network manager, I'm going to move down to the property manager, and again, output type is set to wells. That's good. The sheet type, this is from to data, so I'm going to use from to logs. If I had continuous data, please note that I could change the sheet type to logs and curves. Since I have interval data, from to logs would be the sheet type. And again, you can see that all the required fields and everything that's relevant has now updated in the property manager, which makes it really easy for me to assign everything that I need to. So I'm going to make sure everything's assigned correctly. The well ID looks good. From to, and then log 1 and 2. Wanted to make a quick note about this. This log columns parameter is adjustable. So if you have more than one component or log column, you obviously are going to want to change that log column's value to the number of data columns you want available for rendering along the well trace. I wanted to discuss rendering the interval data along the well trace or the borehole path. So I can render this from to data by first dragging the connector from the samples table to the well data module. When prompted, I'm going to connect input worksheet C. And now I'm going to go ahead and select the well renderer module in the network manager. So right now what we have showing is path data, which is just the well traces. I've added interval data, so I want to go ahead and select the interval data tab in the property manager. And of course I want to show the intervals. I'm going to go ahead and check this box. As far as the data source, we have both from to values and log values. Now again, since I have interval data and from to columns in my samples table, I'm going to go ahead and leave this set to from to values. For the interval log parameter, I have both of the logs that I have assigned for the samples table. I'm going to go ahead and select column D. And you can see that data has now been rendered along the well traces. This is a static color for the whole, for the whole data. So what I'm going to want to do is change the color method to by log. In doing so, I need to specify a color log. I'm interested in rendering the data from column D, so I'm going to go ahead and select it. And as you can see, the data has now been, or the interval data has now been rendered along the well traces. We can enhance this display a little bit by changing the colors, changing the size a little bit. And I also wanted to change the well traces to render the same data as far as the size or diameter of the well traces go. So I'm going to change the size method to by log. And again, for the size log, I'm interested in column D, so I'm going to go ahead and select that. And now you can see that the intervals are clearly delineated with both color and size along the well trace. Now, in order to render multiple variables along the well traces, I can change the size log to one of the other columns that I have set in the samples table. So for example, column E. And if you look closely at the well traces, you'll see that the sizes are going to change, and this is based on column E now. Toggle those back and forth so you can see this a little bit. So as you can see, VOXLER is rendering multivariable data along the well traces or borehole paths. Right here, I have this interval data tab selected, and this is rendering, this color log right here. And when I click the Show Legend, this is going to show the values per this color log. Okay, so now that I've shown you some examples of how to organize your data and how to import and display it, I'd like to finish up the webinar today by showing a few examples of how you can use VOXLER's worksheet to quality control issues with missing, incorrect, or outdated well data. So after data has been imported into VOXLER, the stored data can be accessed in VOXLER's worksheet, where live changes will be updated in the project as soon as they're made in the worksheet. So this hot editing or live editing capability lends itself into making VOXLER an excellent data QC tool. So for this first example, I'd like to show you how VOXLER can solve a missing interval data issue. So as you can see, I have a project open that has a borehole that is obviously missing some data, and you can see that right here. We don't see for MW3. All these other wells have some interval data rendered along them, except MW3. This gives me an indication that there's probably something missing or incorrect in the data. So now let's go ahead and take a look at the data in the worksheet window. So with the samples table selected in the network manager, I'm going to move to the property manager and then click this edit worksheet button. This is going to open up a linked worksheet in the worksheet window. So let's go ahead and do so right now. Okay. So I know the interval data that's being rendered in that project is from, we know that the interval data for this project is being rendered from column E. So we can see that here. So I can scroll down in this project and find that some of the data for MW3 from here to here is missing. So to resolve this situation, I can go back to the source data or the data provider and get a good copy of the data for this particular borehole. So after I get a corrected copy of the data, which for time purposes, I already have this data on my clipboard, I can paste it directly into the live worksheet. So I'm going to go ahead and do. All right, there we go. That looks a little bit better. So after pasting the data into the worksheet in these empty columns or empty cells, I can toggle back to the project, and you can see that the data has now been updated and rendered along the well trace. So this is a very quick and easy way to fix this missing data issue. Okay, so now for the final example today, I would like to show you is related to incorrect well data in a directional survey table. So I have an example project open again, that when I connect the directional survey data to the well data module, here to here, I'll get an error message indicating that VOXLER failed to compute one or more of the well paths stemming from invalid caller directional survey data. So I'll go ahead and show you this. Okay, So here's the error message. It's saying I failed to compute paths for one or more of the wells. Each well must have a valid top and trajectory. So this indicates to me that there might be a problem either in the collars table or the trajectory table, which then again can be easily corrected in the worksheet window. So I'm going to go ahead and take a look at the survey, the directional survey table. Again, having it selected in the Network Manager, and then going down to the worksheet and clicking this Edit Worksheet button. Now that we see the table, as this link table is open in the worksheet, I'm going to kind of scroll down and see if I see any issues. And right off the bat, it's pretty obvious what the issue is here. This well ID should be MW2 instead of MW22. So this issue can be easily resolved by making sure that this well ID has been changed, and I can use the data transform command. Notice I have all of these well IDs highlighted. In the transform dialog, I can change this by using A equals MW2, and again that's in quotes because this is a text value. Now that I have the transform equation, looks correct, I'm going to go ahead and click OK to make the changes in the worksheet. Great. So now that you can see the well ID has been corrected for NW2, and if I tab back to the project, you can see that these wells are all now deviated as expected. So that concludes my presentation of the Visualizing 3D Well Data in VOXLER webinar.
So you just saw the basics of how to work with drill holes, but resource estimation is much more than that. So allow me to present another section explained by the people from Golden Software on how they process the data from the holes to prepare for a resource estimation. And then after that, I promise I will show you how I do it.
Welcome to the VOXLER 3 New Features webinar. The new features I will be reviewing are draping images over height fields, adding labels to the scatter plots, rendering well data in VOXLER, using the face renderer in VOXLER, getting volume calculations from VOXLER. I'll first go over draping an orthophoto or aerial image over a height field. The first step is to start a new project, and I will use File Import. When the import dialog opens, I'll navigate to the grid and click Open. We see the Lattice Import Options dialog open. I will choose to load the grid as a curvilinear lattice. Loading the grid as a curvilinear lattice will locate the grid at the correct Z level. Now let's add a height field module to the data by selecting the grid in the Network Manager, right-clicking, and choosing Graphics Output Height Field. Next, let's load the orthophoto by using the File Import command. When the import dialog opens, I'm going to navigate to the image and click Open. Now that the image is loaded into VOXLER, let's attach a height field to it by dragging the connector from the image to the height field. And when the context menu opens, let's choose Connect Input Overlay. I'm going to make sure the height field is selected in the Network Manager and move to the Property Manager and select the Overlay tab. Next, I'll click the Show Overlay. Since the image I'm using is georeferenced to the same system as the grid I'm using, I'll select the Clip to Surface for the Fit option. For color modulation, I will switch to Use overlay color only. And as you can see, this creates a great looking model that is ready for some 3D data to be added to it. The next feature I'll be talking about is VOXLER's ability to label scatter plots. I'm going to stick with the current project I have and add a scatter plot. So let's bring in the source data by using the file import command. When the import dialog opens, let's navigate to the source file and click open. There we go. Now the select data columns dialog opens. This is a very important dialog in VOXLER to know your way around. I'll show you why in a little bit later in the webinar, as we'll see this dialog multiple times. Since we're going to create a scatter plot, I'm going to choose to import as points. I'm going to set the X, Y, and Z and C columns appropriately. I'm going to set the elevation to the single component here. And most importantly, I'm going to make sure that I have the import labels checkbox checked and the correct column set. Everything looks okay, so I'm going to click OK. I'm now going to attach a scatter plot to the source data in the Network Manager by right-clicking, choosing Graphics Output, Scatter Plot. As you can see, here's the scatter plot. Now I'm going to show a few of the different label options for the scatter plot. I'm going to make sure the scatter plot is selected in the Network Manager. I'm going to move down to the Property Manager and make sure the Labels tab is selected. Now I'm going to click the Show Labels. And I'm going to move the labels offset just a little bit so we can see them a little bit better. There we go. And you can see that there's also label format options and font options. You can also show leader lines to the points. So let me zoom in here a little bit so we can see this. Let's say I wanted to extract the log values along the well traces to use input to a gritter module so I can create things like ISO surfaces, ball renders, face renders, etc. I can do so by adding an extract points module to the well data module. I will do so by right-clicking on the well data module, choosing computational extract points. Additionally, a gritter can be added to the extract points module by right-clicking on the extract points module and using computational gritter. Once the gritter is added, the data can be gridded and any of VOXLER's grid-based modules can be added. Okay, so let's talk about the face render. First, I'm going to grid this data that we extracted from the well data by clicking the Begin Gridding button. Okay, so VOXLER's face render module creates a 3D block model that's capable of creating discrete voxels defined by the input data. Target component values can be isolated and displayed by different colored blocks. I'm going to add a face render to the model by selecting the gritter module in the Network Manager, right-clicking, choosing Graphics Output, Face Render. And let's zoom out a little bit so you can see this. You'll notice that the entire volume is now filled with the face render. This can be adjusted by isolating target component values by adjusting the color map. And I'll show you how to do that right now. So I'm going to make sure that the face render is selected in the Network Manager, move down to the Property Manager, select the General tab. I'm going to change the color map really quick here. And then I'm going to click the ellipses button next to color map to access the color map editor. Now that the color map editor is open, I can control the component values that the face render displays by adjusting the opacity mapping section of the dialog. You can see there's opacity mapping and the color mapping histograms here. Let's say, for example, I had an interesting scene where the component concentrations of 0.295 and lower are located within the model. I will add a few nodes to the opacity histogram, drag one to the bottom, and assign a 0.295 as the data in the data value box. I'm going to do it for the other node as well. Sure this one got it too. Now you can see that the component value has been isolated at 0.295 and below. I'm going to close the color map editor. The face render can also be controlled by the limit sliders found on the geometry tab. So what I'm going to do is I'm going to adjust that color map so we see the entire block again. Select the geometry tab, and we have these slider controls. Just a little better view there. So VOXLER allows you to calculate volumes in two different ways. So let me adjust the face renderer back to where we were here. And as I was saying, the face render module can compute volumes by checking the compute volume checkbox. Right below the compute volume checkbox is an approximate value being displayed. VOXLER uses the block count of the isolated component values to compute this volume. I can also find the volume of an isosurface. So I'm going to add an isosurface to the model by selecting the gritter module in the network manager, right-clicking, and using graphics output isosurface. I'm going to change the color map to a matching color map, and I'm going to set the ISO value to 0.295 since that's what we were using for the face render also. Now you can see the isosurfaces roughly emulate the face render. To get the volume calculation from the isosurface, I'll select the isosurface in the network manager, move to the property manager, make sure the general tab is selected, and again check the compute volume. Now you can see the volume is displayed greater than and less than the isosurface. And as you can see, the volume is displayed for both. That concludes this presentation of the top 5 new features in VOXLER 3. Thank you for your time.
So here we are at VOXLER, and we're going to start by importing the grid that we just made on Surfer. So go to and this is important. We need to import it as a curvilinear lattice, which means that it will be adjusted to the level of the sea. Next, we import the image. Now, right-click on the grid, go to Outputs, and select Hide Fill. And then link, just click and drag. When you see it's yellow, it means that it's linked. And click on Overlay Not Connected. And now we have our image that we got from Surfer adjusted to our area. As it was the case with our previous episode, the easiest way to work with these programs is to use an example as a template. As I mentioned before, I will put all this information on Mendeley, and there will be a link where you can download all the data. So I'm going to show you quickly how you can do the resource estimation, actually the volume for the resource estimation. The only thing that you need to do when you have this template here is to download the color, the trajectory, and the analysis. So what you do, you just find these files in your directory and you put your own data. And then you just select. On the previous part of this episode, I show you how to do the color and the digital elevation model, so to get a high field strength, which is this one here. Also download the color and do a scatter plot, and that will show a location of all the holes. But then you just import the color, the trajectory, and the assay, and now you get the locations of the holes on the ground. All these manipulations, for example, the word render is to make the holes. You could take a buffer on, but this is done automatically as soon as you highlight these cells here. So the next two steps are to extract the points. You will not see anything, and the grider. Now, the grider is very important. You can manipulate the way you're going to do the geometry of your blocks. So you can write the resolution of your block 50 by 50 by 50, what the system recommends, but you can change that to 20 by 20 by 20, whatever. You can also select what type of search type you're going to use, isotropic, general, simple. And then when you are ready and satisfied, you just click begin the gridding. You notice the yellow spot. It means that it's working. And when it will be done, it will become green. Now, there are two ways of estimating the volume for your deposit: the phase render way and the isosurface. The isosurface is faster, and we will see why, but people are used to see the phase render, these little blocks here that GenCam does. So in this case, the approximate volume, this is in cubic meters, it's 6,180,859 cubic meters. So you just write down that number. But that volume is for what cutoff? So here is where you establish the cutoff. You click on the points and you adjust these links to the cutoff that you want. Let's say you want a cutoff of 1.5. So you click right 1.5 there, and then 1.5 here. And that's it. That is your new volume for a different cutoff. So you write down that volume, which is now 2,144,251. So you can do this for different cutoff and update the graphic, and then you can cut this thing off and put it on the report, etc. I usually take off the colors. People are more interested in this part of the graphic. Now, how isosurface work? With isosurface, it's much easier to do the volume estimation because you can just type here or write the different numbers that you want. For example, for 1.8, and it is immediately, it adjusts the volume of the deposit, and you have the volume that is bigger than this line. That's the one that you're going to be using, and the rest of the volume. So you're going to be using this one. So you can change the ISO values, and you will get different volumes here. So this is how it is done. You just select the different cutoff that you want and write down the volume. Then you multiply the volume by the density, and that will give you the million tons by the average value, which is, by the way, here is giving you the average value for that block. So use a combination of the phase render and the ISO surface, and you will get all the information that you need to do your resource estimation. With this, I will end Golden Droplets episode 29, and I see you in Golden Droplet 30, where I think I will be talking about another method of resource estimation, intertext. Until then, wishing you health, both mentally and physically. Have a good day.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.